Hi, this is Stephen, and in today's video we will discuss how to estimate cardiac output with echocardiography. So let's start with our apical four-chamber view. You have the left atrium that empties blood into the left ventricle. You have the right ventricle and your right atrium. And if I tip my ultrasound probe towards the patient's head, I'll actually be able to see the LVOT and aortic valve. Sometimes this is referred to as the five-chamber view. I'll see that pop in right here. And what I can do is I can actually use pulse wave Doppler to measure the velocity right at the LVOT. That's the velocity of blood as it's leaving. What will we see? Well, we will see a graph that looks something like this. So on the y-axis, it's velocity, so centimeters per second. And on the x-axis, it's time in seconds. And you'll see something like this. You'll see with each heartbeat, you'll see the velocity profile of blood as it leaves the heart in the left ventricular outflow tract. And if you were to measure the area under the curve, if we look at the units, what would that be? Well, that would be centimeters per second times second. So it gives you a length in centimeters. We call that length the time velocity integral, TVI. And what does that mean? Well, I want you to imagine here that we've got a little slug of blood that is pumped out with each, we'll draw it all in red actually, a little slug of blood that's pumped out with each heartbeat. The question is, what are the dimensions of this cylinder? Because if we can figure out those dimensions, then we know stroke volume. And to get the length, this length is actually the time velocity integral. Now, how do we get the diameter of this cylinder? Well, for that, let's look at a different view, the peristernal long view. So you've got your left atrium that empties into your left ventricle. You've got your aortic valve leaflets. The valve is wide open. We're in systole when the blood is being pumped out. A little thickness to the LV there, and your RV is up here. And if we measure right before the cusps, this diameter right there, that is the, oops, let's zoom back in, that is the LVOT diameter. And let's give some numbers. So let's say that our LVOT diameter is often around 2 centimeters, so we'll say that's about 2 centimeters. And let's say that our TVI that we measured before would be about 20 centimeters. How can we calculate for this cylinder? Well, we have the length from our TVI, and we have the diameter right here. So the volume of this cylinder is nothing more than pi r squared times the length. That will be the stroke volume. Well, let's put some numbers in. Pi, the radius, we said the LVOT diameter is 2, so the radius will be 1. 1 squared times the length of the cylinder, that's the TVI, which we said was 20. That will equal about 63 milliliters. So 63 millimeters is our estimated stroke volume. Just to give you an idea of some normal numbers you can keep in mind, if we said that we have because remember, cardiac output equals stroke volume times heart rate. And so if we were to take a stroke volume of about 70 milliliters and a heart rate of about 70 beats per minute, both of which would be normal values, that would give us 4,900 mils per beat, or that's about 5 liters per minute, which is normal. So if you want to remember some normal numbers, 70 mils per beat, 70 beats per minute roughly corresponds to 5 liters per minute of cardiac output. Now, you may have been wondering whether we could calculate stroke volume a different way based on our our previous videos, and in particular, you may have been wondering, well, I thought from the apical 4 chamber, we can measure the largest volume, and we can also measure the smallest volume. I'm exaggerating a little bit here, but if we were to figure out from the apical 4 chamber and apical 2 chamber, and we were to get a volume here, and we were to get another small volume here, and we take the difference between those, wouldn't that also be the stroke volume? And the answer is yes, that actually could also be the stroke volume. So that's another way to check your work. But most typically, when we're calculating stroke volume, we'll use this method of measuring the velocity and the diameter right at the LVOT, and then we can multiply the TVI by the cross-sectional area of that cylinder, and that gives us cardiac output.